Okay, so part 8 we did yesterday, and we talked about a couple things. We talked about how to define the degree of a function. This one is just y equals x squared, so it's real easy to see. It's only a monomial. So the degree of this function is 2. And as you were doing the packet yesterday, the degree of the function should have indicated certain things about the end behavior. We noticed that the degree of this function is 2, which is an even number. And as you went through the packet, hopefully you noticed that when the degree of the function was even, the ends of the graph did the same thing. So if the left end was going up, the right end was going up. If the left side was going down, the right side was going down. So in this case, the function has an even degree, and when the leading coefficient is positive, this is assumed to be a positive 1x squared. So if it's even and the leading coefficient is positive, the ends of the graph both rise. So whether or not x was approaching negative infinity or positive infinity, the y values were both approaching positive infinity. So that's one thing that as we look at them, as we go through, notice when the degree of the entire function is even, that both the ends will either be rising or falling. If it's even and the leading coefficient is positive, then both of them will be going up. If it's even and negative, as we'll look at the next one, the ends will be going down. They do the same thing. So end behavior is one of the characteristics of a polynomial function that is determined by the degree of the function and the leading coefficient. Those are the two things we're looking at. Degree and leading coefficient gives us end behavior. Now the second thing that you should have noticed as you looked at all the different polynomial functions from the packet is that when the factors are raised to powers, it has an effect on what happens at those x-intercepts. So if we look at this problem, x squared could be written x minus 0 squared. So this factor is being squared. X minus 0 tells us there's an x-intercept where? At 0, 0. And if the x-intercept is at 0, 0, and it's raised to an even power, when that factor is raised to an even power, it's going to be tangent at that x-intercept. It's going to touch and bounce back. It will not pass through the x-axis. It touches and bounces back. And yesterday we defined tangency as where it touches in one point and bounces back. So if the factor is raised to an even power, so this one only has one factor, right? X minus 0 squared. That is our only factor. So right here at 0, 0, it's going to touch and bounce back. Now, let's compare A and B. B gave you the exact same graph of A, except it was reflected over the x-axis. So, it still has an even degree, but there's a negative leading coefficient. So the ends of the graph are doing the same thing, but because the leading coefficient is negative, instead of going up, it's going down. So, if the entire function has an even degree, going up, everybody do this, going up, even positive, even positive. All right, both ends are going up. Even with a negative leading coefficient, what's happening? Both are going down. Okay? Even positive, even negative. Even positive, even negative. That's what the ends of our graph are doing. Okay. This still has just this one factor, and that one factor is raised to an even power. So, the power of the factors tells us what's happening at the x-intercepts. So if a factor is raised to an even power, it is touching and bouncing back. It is touching that x-axis and bouncing back. It will not pass through. That's called tangent, right? Okay, here we were asked to compare the graphs of A and B. A opens behavior is approaching positive infinity, the y values. B is opening down, therefore its end behavior, the y, is approaching negative infinity. Those are its differences. They look exactly the same, except it's been reflected over the x-axis. That could be your similarity. Okay, now, C is different because now our factor is raised to the third power, and the degree of this function is 3. Whenever the degree of a function is odd, instead of the ends doing the same thing, they're going to do opposites. Okay? So, in this case, it's going to fall to the left and rise to the right. So, odd with a positive leading coefficient falls to the left, rises to the right. Falls to the left, rises to the right. Let's do it. Arms. Falls to the left, rises to the right. That's odd with a positive leading coefficient. Okay? Now what's going to happen? What do you think will happen if it's odd with a negative leading coefficient? You got it. It goes from this to this. It just reflects it. So odd and positive, odd and negative. Okay. So an odd degree, the positive leading coefficient, as x approaches negative infinity, y approaches negative infinity. I can yell. I'm going to talk y. So as x approaches positive infinity, y approaches positive infinity. Now, this factor is raised to an odd power. So at the x-axis, it will pass through. Whenever a factor is raised to an odd power, it passes through that x-intercept. Now, when that odd power happens to be greater than 1, so if it's 3, 5, 7, 9, if the power of the factor is odd and greater than 1, not only does it pass through, but do you see how it passes through and it changes the curvature of the graph? It goes from concave down to concave up. It makes a little squiggle at that point. It looks like there's a squiggle at the graph. So where a graph changes curvature from concave down to concave up, or vice versa, concave up to concave down, that point is called an inflection point. So if a factor is raised to an odd power greater than 1, that x-intercept becomes an inflection point for the graph. Do you see how the curve goes from curving like this to curving like this? So there's an inflection, and we call it a squiggle. But it's an inflection point where the curvature of the graph at that point changes from concave up to concave down, or concave down to concave up. Okay. Let's look at D. It is also an odd degree polynomial. It's a degree of 3. So look at the end behavior. Are they opposites? Yes, they're opposites. D has a degree of 3 and a negative leading coefficient. So this time it's going to rise to the left and fall to the right. Now, everything else is just like the other one. This time we go from concave up to concave down. There is still an inflection point there. The curvature of the graph changes because this factor is raised to an odd power greater than 1. So it causes an inflection point at the x-intercept because the curvature of the graph changes at that point. Still going to pass through, just passes through with an inflection. Did you get most of that? So far so good? Okay, so 2 major things. End behavior, even positive, even negative. Odd positive, odd negative. Okay? So end behavior is one of the things. And the second thing is, what is happening at the x-intercepts? Is the graph tangent at the x-intercepts? It is when the factor is
even power, or does it pass through at the x-intercept? That is when our factor is raised to an odd power. Okay, now let's look at the next one, because these are all raised to odd powers, but they're just raised to the first power. And do you see how it passes through these x-intercepts? But is there any inflection? Does the curvature of the graph change at all? No, it kind of looks like it goes through like a straight line, doesn't it? Okay, so if it's just to the first power, which most of the time when it's to the first power, will there be a 1 there? No, it'll just be understood. So we're going to pass through, we're going to pass through, we're going to pass through all those x-intercepts. Our end behavior is the same as it was for C, because it's odd and positive. So it falls to the left, it rises to the right. As x approaches negative infinity, y approaches negative infinity. As x approaches positive infinity, y approaches positive infinity. Okay, questions about that? All right, next one. We have the same x-intercepts. We have the same degree, but because it's negative here, this time we're rising to the left and falling to the right. So the end behavior rises to the left, so as x approaches negative infinity, y approaches positive infinity. And it falls to the right. As x approaches positive infinity, y approaches negative infinity. And then it's going to pass through all of those intercepts. X-intercepts. That's what I should have said instead of zeros of the function. I'm going to say x-intercepts. All right. G. Now this is a good one. How do we know this one has a degree of 4? What can we do to find the degree of a function? Add up the exponents. Because this is a product, because I'm multiplying like bases, I add the exponents. 2 plus 1 plus 1 is 4. So it's even and positive. Rise, rise. Even degree and positive. Both ends rise. Rises to the left, rises to the right. Okay, we still have 3 x-intercepts. Now if we look at this factor here, x minus 0 squared. So one of our x-intercepts is 0, 0. But because this factor is squared, what does it do at 0, 0? It bounces. It is tangent at 0, 0. And then we have x plus 2, which means I have an x-intercept at negative 2. That is raised to the first power. Because it's raised to an odd power, it's going to pass through there. So it passes through negative 2. And x minus 1 tells me there is an x-intercept at 1, 0. And it's going to pass through there also, because that is raised to the first power. Okay, so when the factors are raised to even powers, it bounces. It is tangent at that point. When the factors are raised to odd powers, it passes through. Any questions about G? All right, H. This one has a degree of 5 because 2 plus 2 plus the understood 1 make 5. Odd, opposite. When it's odd and negative, it's going to rise to the left and fall to the right. Rise to the left and fall to the right. So what we're getting to is to the point where we can graph these without a calculator. And that's how you would want to think about this one. How would we go about that? Let's recreate this graph together right now. How can we make this graph without picking up Desmos, without picking up a graphing calculator? Step 1 is to find your x-intercepts. I have an x-intercept at 0. I have an x-intercept at negative 2, 0. And I have an x-intercept at positive 1, 0. So that's step 1, intercepts. Step 2 is, what is my end behavior doing? If the degree of the function is 5 and the leading coefficient is negative, it's going to rise to the left and fall to the right. And then we look at each individual x-intercept. -2. Okay, -2 is squared. Is it going to bounce or pass?
Bounce.
Bounce, because the factor is even. Bounces back. Okay, now let's look at 0. It is to an odd power, so what's it going to do? It's going to pass through, so let's curve it back down and make it go through. And then let's look at -1. What's it going to do? Excuse me, a +1. It's going to bounce, so make it go back up and bounce back down. So without a calculator, we can graph these. Yes, Clay?
How do you know how far up to go for like your
We don't care
Okay.
right now. That was a great question. How do we know where these extrema are? This local max and this local min? We don't know.
Okay.
And you're not responsible for that on the no calculator portion.
Okay. And then to find the x-intercepts, you flip the signs.
To find the x-intercepts, it's what value of x makes this factor equal 0. And in this case, yeah, that's all we do.
Okay.
Because there was no, if we had
Oh, it
like
doesn't make
2x minus 1, it would have to be +1/2, but all of these are quite simple. Just the opposite. Okay, so this one. All of these factors are to the second power. It bounced, it bounced, it bounced. It's an even degree with a leading coefficient that's negative. Fall, fall. Okay, I want you to try J now without a calculator. Try J without a calculator.
Wait. I really have a question. Okay, so we didn't flip the signs because there wasn't right?
Right.
Okay. So that was just that one.
You flip the
Because I have a
ends.
negative.
The ends get flipped if there's a negative.
Okay.
Negative out in front affects either up or down.
Okay. But I wouldn't flip these for the x-intercept.
Okay, for the x-intercepts, what can you plug in here that makes it 0?
0.
What can you plug in here?
Negative 0.
I see where you get 5.
The y value from the x-axis is always 0. So find the x-intercepts. You're figuring
It
out
has
what
to be set to
power.
0.
Okay, that makes sense, right?
So if it's a 2, it's.
This will be context one more.
I don't understand the.
The big test where it's a whole bunch of points. So this quiz may or may not be. Maybe it's 10.
I have another question.
So you need some help.
Yeah, I need to come back.
I guess instead of like doing
I'm
stuff,
gonna go back.
just let that.
I felt small on the first one.
I have another question.
I get that you
How do we know if it flips up or down again?
Hey, it's 2,
What do I do with 5, man?
4, 5. The degree of
five's an
function
odd
is
number.
5.
Okay.
The leading coefficient is positive. So it's
Okay, so
all
5
to
is.
the
I
left.
mean,
Rise.
alright, what is 4?
How did you know that?
Me and Trevor on there
How you know?
together.
Okay, because of what we
Four's
learned
the
over here.
Because you count the number of exponents.
Okay.
We had a second period.
Odd and positive falls to the left, rises to the right.
Okay.
Okay, so every time we had odd and positive, there's another one, right here.
Right?
Odd and positive falls to the left, rises to the right.
Odd,
Miscalculation.
positive.
Yours is wrong.
Huh?
Okay,
Because squared is bounce. Don't square bounce.
We're allowed to move the next
You don't have to do
That's exactly what happened.
Yeah, I'm not gonna bounce.
I don't know.
Okay.
What the heck? examples on the board.
Do you realize that?
Yeah, they were.
Do you realize
We did it on Monday.
I'm more of a blocker with office?
How did you
On that quiz?
It's like, I'll take the $40.
Bounce.
You would lose probably $1 billion on that bet. I don't think so. I guarantee you that. It's like I can score with percents of gold. Like it to the quarterback gives it back. Yeah, you're right. Like yo, and then he throws it right back. That kind of throw, or would it be a handoff? It's going forward. But like I'm the center and I snap it back and I keep my hands here, and he gives it right back. They do that more. I think that worked pretty well.
Okay. So mine's up there, but let me redraw it where we can see it happen together. First thing you have to do is figure out your intercepts. Alright, so 0 is going to be an intercept. Change its colors.
-2.
Okay, -2 makes that factor 0, good. And what makes this factor 0? 1. So those are my 3 x-intercepts. Now the degree of this function is 5, because 2 plus 2 plus 1 is 5.
So they all add up.
Uh-huh.
Yep.
And the leading coefficient is positive, so it's going to fall to the left, rise to the right. Now, let's talk about what's happening at these roots. Let's look at -2 first. This factor is raised to an even power. So what does it do at this x-intercept? Bounces. Okay, now let's look at 0.
How do you know it goes down?
Because
Instead of
if
up.
it bounces, that's the only thing it can do.
Oh, okay.
Okay? Now this one, 0, is also going to bounce. So we got to go back up so we can bounce back down. And then at +1, it is the first power, so it's going to pass through. Pass through.
It's all bouncing.
Okay? So, guys, I want you to quickly take a picture of this, because this is a summary of everything we've talked about. So if you guys have a phone, take out your phone. Huh?
I don't have a phone. I got my phone.
Okay, this will be on my notes.
Not enough.
So I can print it out for you, or you can print it out for yourself. It'll be posted to my website.
Last period, she just wanted to get the teacher email.
Yeah, it was like, can you send an email to my mom saying you want
No, your mom's probably being a good parent. Alright, so in behavior, we look at the degree of the function. If it's even and positive, it rises to the left and the right. If it's even and negative, it falls. If it's odd and positive, it falls to the left and rises to the right. If it's odd and negative, it rises to the left and falls to the right. Now the root behavior, we're going to talk about this tomorrow. There's one more word I can use to describe this called multiplicity of the root. We'll talk about that word tomorrow. But if it's an even power, it is tangent at that intercept. If it is odd, it passes through. If it's odd into the first power, it passes through as if it were a line. And if it's odd to a higher degree,